through of the midterm 2 practice test, and so I'll just be writing some stuff on the document here and kind of working through how I think about it. Okay, so let's get started. Oh wait, I gotta make a little space for somehow even. Okay. So this first question is about classes and the structure of classes, and really just the terminology associated with object-oriented programming. Again, we can't talk meaningfully about these concepts unless we know a few terms. And so here are some terms, and here is a class, and the idea is that I'm going to fill in the blank with the thing that is immediately before the blank. So I'm going to go down, down the list. Here we have class test. Test is the class name. What is this thing here? Again, we've talked about private and public. Private is only accessible from code inside the class. Public is accessible to code anywhere. You might have to import that class. It might have to be in the same package, but you can still access it somehow. So this is an access level modifier. And then immediately after it, what is it controlling the access to? It's controlling the access to this piece of storage inside the class that we call an instance variable. And then here we have our first method-like thing. This one is a constructor. It tells Java how to build an object of the test class. In this particular case, it has no parameters coming in, but it does set the instance variable to some initial value. Of course, this is sort of a meaningless thing right now, but it's still acting as a constructor. So this is 3. This one, we have a more general method. In fact, I was looking around for method in the list of terminologies, but this is often has a specific purpose. It is to take this private instance variable and provide access to it to the larger world through a public interface. And this thing we call a getter. Normally with a getter, is often paired with a setter, which takes in a new value and assigns that internal instance variable to that value. And then we might have general methods as well. But really, those are all the main parts of a class. And again, one difficulty with object-oriented programming is that construct is larger than, say, just like an if statement or a loop. It spans many lines, has many parts, but they all work together to provide a certain purpose. All right. Second question. This one has really a lot of code for not doing very much. So what do we have here? There's a class C. So again, we're defining a type. We can make instances of class C. And it looks like class C has a single piece of internal storage, a single instance variable, B, and it's an int. And it has a constructor that sets B to 0, which it would do anyway. Like if I didn't have any constructor, the default constructor that's invisibly provided as long as you don't have a constructor would default initialize all the instance variables. And in this case, since it's an int, the default initialization is 0. And then it looks like we have a general method that adds 1 to that internal instance variable and also prints it out, which again is sort of bad form in the sense that you want to separate out your activities in the methods, and if the job of the method is to add 1 to something, it should add 1, and then something else should print it out. But here I'm just doing it all in one place. And then we have main, and again, the point of main is usually to either sort of set up the program to run or provide little tests for that particular class. And in this case, we're just making a few objects. Okay, so program is going to start in main. We make a new C object, C1, and I'm just going to write down C1, and I'm going to write down the instance variables associated with it. If there are multiple of them, I might just sort of indent them and write, A, B, C, D kind of thing, but since there's one, I'm just going to have C1.b, which is the normal notation you use to get access to that instance variable. and it starts off at 0. All right, so we're going to make a new C object that goes up here. B is 0 and returns. Then I call add 1. So what happens? B gets 1 added to it. It gets incremented. And then we print out B. So down here, output, we get a 1. Then we make another object, C2, and its B instance variable starts off at 0. And then I add 1 to C2. So that variable is now 1, and I print it out. 1. Woohoo! Then I go back to C1 and add 1 to it. Okay, so we know what happens. That turns into a 2, and we print it out. And that's it. So it's not very exciting. Really, the point of this was to really make sure that you understand that when you make two different objects, C1 and C2, each one has its own independent B, right? They're not linked together. And so changing one doesn't change the other. Of course, that's a good thing. If you had a class, you can only make one example of it, then, for example, a person class would be kind of useless unless there's only one person in the world, which there's not. So it's good that each object has its own internal storage for all the instance variables that belong to that class. Okay, let's clear that off. And now we get a little more serious here. This method has got it all. And the point of this thing is it's not about this. The point of this is to force everyone to confront what happens when you pass different types of things to a method. Okay, so briefly what do we have going on here? Again, we're defining a type D, and every object of type D seems to have an internal instance variable V. And then there's this very complicated method that just takes a bunch of values in and seems to add 1 to each of them, right, in different ways. All right, but let's start interpreting this at main, where we should. And I'm going to run out of room probably, unless I'm very careful with my spacing here. But okay, so we're making an F. F is 1. Then I make an integer G equal to 1. Okay, so things to remember about variables of object type, integer is an object type, is that they hold references to the actual object. And so I need to, I shouldn't just write G1 here in some sense. I should probably write like G references, I'm just going to use I for integer that holds a 1 value or something like that, right? So G references an integer object that holds a 1 inside it. And then H is an array. Okay, H. And also H really references an array that has it starts off at 0, and then we assign a 1 to it. So I'm just going to write the little array with a 1 inside it. And now finally we make a D object, I. See, this is why all these one-letter variable names are terrible, because you're like, what are these H, I, F, G, it's hard to track. So I make an I, and that references a D that holds a V, and V starts off, where's the constructor gone? Oh, there's no constructor. It's a default constructor, so it starts off at 0. But in this case, I'm also going to assign a 1 to it right away. Okay, so we have a 1. Phew. Okay, so here we have, F is a primitive, G is a wrapper class, H is a reference to an array, so to an object, and I also is a reference to an instance of the D class. And really, that kind of covers all the things we've sort of learned about so far in terms of, obviously there's different kinds of objects, but this covers sort of the main set of things. Now we call this work method. So again, when you call a method, the value stored in the variable gets assigned to the parameter. So the value stored in f gets assigned to a. All right, we have an a, and that gets a 1 because that's what was in f. Now g, what is stored in there? It is a reference to this integer object. And so b, integer b, references that, this is where it's going to get ugly, huh? That integer object. How about h? H gets, the reference in h gets assigned to c. Well, okay, I'll just keep using the same bad crossing arrow notation, which is going to cause some problems. Okay. And here's where I ran out of room. E gets the reference to the I thing. E, okay, I'm just going to go straight there this time. Gets reference to that D object. All right, so that isn't even what work does. It's just how the parameters get set up, right? The values, either the primitive value or the reference, gets assigned to the parameter in work. Okay, a equals a plus 1. Okay, a was 1, and it turns into 2. Notice f doesn't change, right? Because those are distinct. Now it says b equals b plus 1. This is, again, the tricky thing. We had a good portion of a lecture on the wrapper classes talking about this b equals b plus 1. So what happens here? The b, this integer, gets unboxed to be a 1, an int 1. It gets added together to be a 2, and then that 2 gets auto-boxed and put back in b. That means there is a new int object that has a 2 in it that gets assigned to b down here, right? b is no longer referencing that g integer object. B is now referencing a new integer object that contains a 2. Okay, now C0 equals C0 plus 1, this line here. Well, C references this array. C0 has a 1 in it. We add 1 to it, we get 2, and we assign it back to that same location. This becomes a 2. So notice we did change the internals of that array object. We didn't make a new array, so we didn't have to reassign C down here. C is still referencing the same array that H did, and we changed the value stored inside it. And then for E, we take the value stored in EV, which is this one, 1, add 1 to it, we get 2, and store it back in it. So this becomes a 2. So now when I print them out, F is still a 1. G still points to this integer object that has a 1 in it. All right? This B had changed. It's referencing a new integer object, but that didn't change G. H0, well, we look at H0. The internals of H0 had turned to a 2. And IV, well, it has turned into a 2 as well. So this highlights the main difference when you pass things to a method. Primitives, since the values get assigned to the parameter, it doesn't have a way of propagating that change out to the original code in main somewhere. The way you propagate values out is through a return, right? The integer stuff is tricky because it looks like an object, and an object normally you can change the internals of, like the instance variables. But in this particular case, wrapper classes are immutable. In other words, if an integer stores a 2 inside it, you can't change that to a 3, because the intent is that is like a 2, right? It'd be like changing a primitive 2 to mean 3, and then all of a sudden, you add 2 plus 1 and you get 4 or something like that. It'd be weird because that 2 had turned into a 3. So what happens here is that we're actually assigning a new object to B, and again, that change in reference value doesn't propagate out of the method. For an array, we could change, if I had made a new array here, like c equals new int 5, then I could change that in this method, but it wouldn't propagate out here to the h, because those are two different arrays now. But since I'm changing just the internals of the same array, then that is looking at the same array object, and it does change it, in both places. It's really only one place. Both are looking at the same object, right? And the same kind of thing happens with objects, with internal instance variables, that I can pass a reference to that same object, and I can change the internals of it in the method. If I assigned a new D object to it in the method, that would not propagate out, but I can change the internals, and because they're both looking at the same object. So again, in general, primitives don't change, objects do change, but you have to be careful about immutable ones where you may be reassigning it and maybe don't even realize you're reassigning it. All right. So this is a very complicated method. The rules for doing it are very simple. You pass whatever value stored in a variable to a parameter, and you just go from there. As long as you stick to that, you'll be safe. If you start inventing new things with it, then you're going to get into trouble. So you have to be very disciplined to do it. I mess it up all the time. I get a little sloppy, and all of a sudden I'm changing something I'm not supposed to. But this is the correct way to think about it, right? And you have to force yourself to think the way the computer is going to interpret it, because otherwise it's going to be a surprise when it does something different. Okay, all that work gone. Oh, now this is going to be a little tricky. Let's see, how am I going to shrink this so I can see it? And I don't want to shrink it too much because I got to write in it too. This says, right, so we've done a couple of these variable memory stack heap kind of things. Again, they are a way of enforcing the correct way to think about these programs as they run. So this asks us to write out a plausible variable memory table at the point just before the work method is called. So we got to go up to this line and figure out what's going on here. So let's start at main. Int f equals 1. Okay, so I am declaring a variable f. This is tiny now. That's not going to be very good. And it is of type int. And when you make a variable, it is stored in the stack, no matter what, right? So don't get confused by whether it's a object or a primitive. The variable is stored in the stack. So I'm going to say this goes at the top here. I'm saying build the stack down, and then somewhere down here is so this is the stack up here, and the heap is somewhere, down here. So what gets stored at memory location 1000? Well, whatever value is stored by the variable, which is a 1 here. Okay, that is a beautiful one. We go to the next variable here, where it's a new variable. We have to put it in the table. G is an integer, and it just goes to the next spot on the stack. Right? There's no decision making you have to worry about there. When you declare a variable, it gets declared and put on the next spot in the stack. Now, what does it hold? Well, it holds a reference to an integer object that goes somewhere on the heap. And this integer object is going to hold a 1 value. So I'm going to build, it has somewhere that 1 value goes. This is the G object, and I store, this is really, let's say, an integer object. And G has a reference to this. So the G variable spot holds the location of this integer object here, right? So G is stored on the stack, 1004, and stored in 1004 is a reference to this integer object down here. There's that indirection involved, which makes this more complicated. All right, next we have an int array H. It is an int array, and it is a variable, so it gets stored the next spot in the stack here. And what gets stored? Well, to be honest, we don't know exactly how an int array is stored, but it's going to go somewhere on the heap, and there's at least space for one of these ints, and it has a 1 stored in it. So there's a 1 here, and the reference, the location of it, is stored in the variable. Then I make an I object, an I variable of type D, and it goes in the next spot in the stack, 10, 12. And D gets made somewhere, and it has space for one instance variable that's an int that has a 1 in it. I'm going to put it here at 1024. 1024. Okay. So that's a plausible representation. Basically, the main thing is, as I see the variables declared one at a time, I fill out this variable table. As they get added to the stack. And if they are assigned an object, then that object is put in the heap, and its location, it gets stored as a reference back where the variable is. Now, of course, the stack's a little more complicated. If I call a method, we add the parameters on the stack, and then when we leave the method, those get popped off the stack. So there's this building and growing and shrinking process with the stack as code runs. The heap stuff, again, these objects stick around as long as they are referenced by some variable. When they're not referenced by a variable, they get marked somehow. And this thing called the garbage collector eventually clears them out of memory and says that memory is now available for other code to use. All right. So again, a kind of complicated process, but the basics of it are simple rules that you follow. When you see a variable, you declare it here, you add it to the stack, and you figure out if it's a primitive value, the primitive value gets stored. If it's an object type, you build the object in the heap and store the reference in that location. All right, this final one. If I had a person class with age and name instance variables, a constructor that you pass in values for those, and a getter for each instance variable. So instead of writing that on paper, let's just write that in code, so we can do a little more full version of it. So a person class, it has instance variables. Oops, let me move my keyboard around where I can use it now, since I have to type. Okay, so instance variables are typically private unless there's some compelling reason not to make them private. It asks for an age, which is an int, and then a name, which is going to be a string. Oops. Okay, so I have two instance variables. I need to make a public constructor, which is, again, it's public, and then the name of the class. And I want to pass in some values to initialize these instance variables. And so I could have int starting age and string. I'm going to leave that name just to kind of talk about some options here. And again, the job of the constructor is to set up an instance of the person class in some meaningful way, some consistent, self-consistent way. So I could say age equals starting age. And again, sometimes I see people doing that backwards. They say like starting age equals age. This thing, the instance variable, is the one that persists around, and so I need to get a value from the parameter and put it in the instance variable. For name, well, there's a ambiguity here. Which name do we mean? The scope of this name starts by checking the closest scope it can resolve to, which is if there was a local variable name or a parameter name, that's the one it's used. So this is actually assigning to itself name. If I want to get to the instance variable here, I can prepend it with this dot. And again, this is a keyword that means any object that you build of the person type that calls a constructor is that's what this references. So let's make one of these things before we get any further. So okay, so we need I'm going to make a declare person variable, and then I have to say it's a new person, and I pass in a starting age and a name. So 10 gets assigned to starting age. The string reference gets assigned to the name here. We assign age just with starting age. Starting age gets assigned to age. And David gets assigned to this.name. This is the object that is calling this person constructor. It's a little hidden in this particular case because we don't say like me.person here. But when you call a constructor, really that it's this object. So this references the same object as this, which means that this.name is really the me.name that's getting assigned for this particular case. If I had another object you and you. In this case, when the constructor is called, this references the you person object. All right, so this is a stand-in. It's a general identifier that this is an object and this is its instance variable. Okay, then we're supposed to write some a getter for each instance variable. All right, so those are public. Then you have to say what's being returned out of this thing, public int. And I'm going to do a get age. You don't pass any values in. You're asking the object what its age is, and I just return age. And again, really that is returning the age that belongs to the object that called get age, but we typically leave those off unless it's needed. And public string get name, and I'm returning name. And so if I were to print out me dot get name and me dot get age, and I run it, prints those out. And of course, if I were to do that with you, then it gets out the stored instance variables associated with that particular object, which are different, right? Okay, so that's all that is required, but it is important that you're able to, given a brief specification of the kind of information stored in a desired class and a few methods that do something with it, that you can, get that rough form out. And there's, you have to kind of, I have to have a little checklist. Okay, a constructor is public and just the name of the class. It doesn't have a return type, right? You're going to need parameters to assign things to each of these instance variables. So it kind of defines the structure. Getters are going to return whatever the type is of the thing they're being asked for, and they're typically just a return value inside there. Setters are the opposite. They're void, and you have to pass a value in because you're going to be changing the internal value. And then general methods, it depends on what it's trying to do. All right, I think that's it. Good luck on your test at the end of the week here. And make sure you're going over the list of topics that's posted on this week, and that you try to do this yourself by hand, especially some of those complicated things like those that passing all those different values to the method and things like that. All right, bye.